Okay. So our height is 15. Our dx over dt is 5 feet per second.
Okay.
Um, and our 6 foot tall man. Okay, so I guess another y value would be 6 feet. Okay, so I guess drawing. So in our snapshot, our x would be 40 feet. And I guess the man would be 6 feet tall, and we'd have to draw that as well.
Yeah.
Be another value of x left over on this side right there. That's what we want to find.
Okay. Yeah. This is shadow.
Shadow.
Okay. Yeah. So for these kinds of problems, the shadow and light problems, what kind of shapes are we dealing with?
Triangles.
Okay, triangles, right? And what triangles do you see here?
Right triangles. And
how many do you see?
Two. They're two
Okay.
like similar triangles.
Similar triangles. Okay. If they're similar, then what can we set up?
Oh, that's right. Okay. Like a ratio, sort of.
Yeah,
Okay.
exactly. And set up a ratio, right? So what would that be? Okay. Actually, no. This should be. Let's actually redo this because we have to figure out what the right x to label is. Actually, I don't think that would work. Now I think about it. What do you think we should label the x?
The entire like distance from the base of the light pole to the tip of the shadow.
I think we should. Well, what's the derivative they give us?
Oh, it's how far he's walking away, or how fast, like his how fast he's walking away. So that means it should just be the distance between the man and the lamppost.
Yeah, because this should be the variable. The tip. So the tip of the shadow, it should be how fast the tip of the shadow is. That should be y. Does that make sense? So where's the tip of the shadow should be this? So this whole thing should be y.
Oh, okay. And then x is 40.
And then we'll be labeled this then. Well, x is still x because that still changes, but we'll be labeled this then.
Y minus x.
Yeah, y minus. That's how it should be done. Yeah, sorry about that. Yeah, that makes sense because the tip of the shadow is the whole thing, right? It's the whole distance away from the light, so that's why we have to call that y. All right, so now we have the ratio. I think so. Yeah, we do. Y. What's the ratio now then, or the proportion?
Y over 15 is equal to y minus x over 6.
Y minus x. Okay.
Over 6.
All right.
To find y, I want to say we want this multiplied by 15.
Okay. What's the next line?
Y equals y minus x over 6 times 15.
Y over, well, let's get rid of the fractions, both of them. So what would that be?
6y is equal to 15y minus x.
Like this.
In parentheses.
Yeah, okay. Can we make this equation easier to work with?
Like expand out the second term, like 15y minus 15x.
Okay. All right, and then what can we do after that? But, well, we have y terms on both sides, right?
Oh, right, of course. Okay, I see what you mean now. So we can just have 15x equal 9y.
Okay. Yeah, and what's the problem asking us?
The derivative, or I guess the derivative of the tip of the shadow of the pole when it's 40 feet away from it.
Right. So how do we find the derivatives then?
Would we take the derivative of that function?
Yeah, because we haven't differentiated at all yet, right? All we've done so far is set up the equation and rewritten it.
Right. Okay. So we differentiate like the last function.
So you don't want to, because you don't plug it in yet, because that just tells you the length. It doesn't tell you anything about the speed.
Got it. Okay. So
Well, what are you differentiating with respect to?
t.
T, right? So that means that x and y are functions of t.
Okay, got it. So it's 5 times dx dt.
5 dx dt. Yeah, that should be it.
Okay, got it. Is equal to 3 dy dt. Oh, and dx dt is 5 feet per second. So 25 feet per second is equal to 3 dy dt. Dy dt is equal to 25 over 3 feet per second.